Merci.
Rosé. Oui.
Should I start? Okay. Okay, so good morning, everyone. Please let me start by thanking the organizers for their kind invitation. Well, kind and not so kind, because what they prepared for us is really tough. So I'm joking. So the title of my lectures is Structure Formation in a Cosmological Context. So it's extremely huge topic. So I will try to do my best and to cover some aspects that I believe are important in the context. Obviously, this is very subjective. I prepared a series of 4 lectures. We will see how it will go. Maybe at some point, given the time, I will decide to skip some parts. But please don't hesitate if you are interested in whatever topic that either I discuss or I don't. Come and see me, discuss with me. I'm staying until the end of this week. Okay? So, sorry. Let's start from the very beginning. So, since essentially the beginning of the scientific era, one of the main goals of astronomy essentially was to map this uneven distribution, or to map the universe, or to understand the universe and map the universe we live in. And probably one of the major leaps toward this goal was to connect this uneven distribution of stars seen in the night sky with the three-dimensional structure of the galaxy we live in. And the first published example of such an idea is this sketch. So this is the map of the Milky Way made by William Herschel in 1785. And Herschel, together with his sister Caroline, also made really extensive catalogs of what was at the time called the nebulae that revealed an extreme diversity of this object, which naturally led people to wonder what these were. And it was William Parsons, an Irish astronomer, who is said to have built what was at the time the biggest telescope in the world with the motivation to understand whether this nebula, such as the one he sketched himself, could be some sort of island universes similar to our own Milky Way. Obviously, at the time, no one really understood that these nebulae were, in fact, the external galaxy to our own. And still, at the beginning of 20th century, there was an ongoing debate among scientists over the size of the universe and the nature of this nebula. So one group of scientists believed that our galaxy was extremely big and it contained all the observed objects, while others believed that our galaxy was much smaller and all these nebulae were sort of external to it. And probably you know, in 1920s was held the debate, famous Gray debate, opposing 2 prominent scientists of the time. Harlow Shapley argued for this one big galaxy, whereas Heber Curtis argued that our galaxy was much smaller and all these nebula were external to it. And so this debate was settled in the mid-1920s thanks to the observations of redshifted nebula, thanks to Vesta Slipher and Edwin Hubble. And this conclusively proved that all these nebula had to be external to our own galaxy and that the universe is probably large enough to contain millions of them. And less than 100 years later, It was again a pure human curiosity that allowed us to understand that our universe in fact contained probably 100 billions of galaxies and that we occupy only tiny space in it. And it was exactly in 1996 when the Hubble Space Telescope, which was the most powerful telescope at that time, was pointed into the region of the sky that contained nothing really interesting in particular. But only after a few days of collecting photons, the processed image that is known as a Hubble Deep Field revealed something like 3,000 of galaxies, and it allowed us for the first time to see, for example, galaxies as they were when the universe was only 1.5 billion years old. So, you know, scientists, they repeat things. So they did it again in 2004. This time they pointed the Hubble Space Telescope with improved detectors into a region of the sky where is Orion constellation. And what came out, you don't see it very well because of the light, but it's this very beautiful picture called the Hubble Ultra Deep Field, which revealed something like 10,000 of galaxies, like really almost each point is a galaxy, showing their huge diversity in terms of sizes, colors, shapes, morphologies. We were able to see how galaxies evolved by interacting and merging. It revealed plenty of examples of galaxies that were already fully formed when the universe had only 40% of its age, such as, for example, these very nice disk-dominated spirals, these bulge-dominated ellipticals, or even this slightly perturbed Bayer galaxy. So as you know, I'm pretty sure you know, today it's a James Webb Space Telescope, Hubble's successor, that continues this sort of legacy with improved detectors, with improved sensitivity, angular resolution, and so on and so forth, that is hunting the really first galaxies, first objects that formed in our universe. In the meantime, it's also showing really beautiful images